Ladies and gentlemen, please welcome Microsoft's Corporate Vice President, Microsoft Azure Application Platform, Bill Staples.
Thank you. It's awesome to be here today at AzureCon with you. And I'm excited to talk about building apps in the cloud. To help us see the incredible opportunities in front of us, let's take just a moment to look briefly at our past. Humankind has long sought for a mechanical means to allow us to think faster with greater precision and more accuracy. The abacus and the slide rule were some of our first mechanical tools invented to speed up arithmetic. But it was the mechanical differencing engine, invented by Charles Babbage in 1832, which provided us an automated tool of sorts. It was crank-powered and could turn out polynomial functions. Perhaps the biggest leap of all, though, was produced by Ada Lovelace. She wrote the first algorithms for Babbage's machine, making her the first real computer programmer. She immediately saw the enormous benefits of building software on top of that hardware. Just 100 years later, the first electrically powered computers were produced. And at first, they were mechanical, but then became fully electric with the ENIAC computer made up of 18,000 vacuum tubes. In fact, this is where the term bug was coined, when a bug, a literal bug, landed on one of those vacuum tubes, shorted it out, and caused a miscalculation. Within 20 years, the transistor was invented and incorporated into computers, which dramatically shrunk their size and improved their speed and reliability. And as computers shrank in size, their market audience grew and grew. The Altair in the mid-'70s inspired Bill Gates and Paul Allen to create the Microsoft we know today. And companies like Microsoft and Apple invented new experiences for both the desktop and the laptop every single year with amazingly powerful hardware and software devices. But the transformation of computing hasn't stopped. The most popular computer for most of us now is the one we hold in our pockets. Did you know that the chip that powers the iPhone 6 has more than 2 billion transistors in it? That's 645 times more transistors in the phone than were in my Pentium computer back in college. In fact, it's estimated on just a single opening weekend, Apple sells more transistors, 25 times more transistors than existed in all the world in 1995. The pace of transformation in computer hardware has been matched by our ability to abstract these complex systems with computer software, operating systems, and applications. Let me give you a really simple example. Right now, you may be wondering, what is he talking about? What does this have to do with building apps in the cloud? In fact, you may be about to tweet that very thought. As your fingertips tap the screen or the keyboard on your device, and you're ready to hit that final send button, have you ever stopped to think about what happens next? I can only describe at a super high level what happens between the communication stack of your phone or your PC and the cloud. But let me give it a shot. When you hit that send button, you probably know it's wired up through means of a high-level programming language to call the Twitter API, hosted on twitter.api.com. After forming an HTTP post message for that endpoint, your tweet's encoded, and the networking layer of your operating system takes the message and packages it up into a series of packets that can be managed by the TCP IP protocols. From here, the LTE radio communication stack built into your phone processes the message and the packet with the packet data convergence protocol, the radio link protocol, the medium access control protocol before passing it off to the hardware for transmission. From there, the message streams around the world, maybe going up to satellites in the atmosphere, back down to Earth, across dozens of routers and switches, through fiber optic lines, through copper lines, and ultimately ending up in one of Twitter's data centers on a server that then decodes the message back up through the Ethernet TCP IP stack and into that original HTTP message that was formed on your phone. From there, a server application takes that message, unencodes it, and calls more APIs to store it in some storage before sending back a response to you. You cared about sharing a thought with the world, and billions of calculations across many devices, all acting in concert, and in less than a second, your wish was granted. And how was your wish granted? By an application programmer conducting a symphony of computational power That's what we mean by building apps in the cloud. Which brings us the challenge of app development. On the one hand, we see the incredible, almost exponential rate of human ingenuity and technological innovation. On the other hand, our ability to keep pace with it, to harness it, is constantly challenged. And there simply aren't enough developers to keep up with demand. Every day when I talk to developers, I hear common questions like, how can I reach every user, no matter where they are in the world and what device they're using? How do I keep pace with innovation as it accelerates? And how can I stay open and agile with new techniques and approaches as they evolve? And these are the key themes that I want to focus on today. But the key thing to remember is that you can answer these questions, you can solve these problems not by writing volumes of code for yourself, but like Isaac Newton once said, we can answer them by standing on the shoulders of giants. Just like the Twitter app developer didn't write the TCP/IP stack or the LTE stack on the phone, you can take advantage of powerful cloud services to accelerate your own app innovation. You see, the cloud promises application developers more than just millions of cores of compute power, exabytes of storage, or terabytes of bandwidth per second. Microsoft Azure provides a platform and data services that abstract the complexity of both hardware and virtual machinery, as well as tools with developer services that make application development more productive, allowing us to focus on really what matters most to us, our apps. And thousands of developers like yourself have already begun taking advantage of these services with great success. Today, I've invited a few special guests to come share their story and how they're approaching those key themes. Today, you'll hear from NASCAR, from Alaska Airlines, and from Mesosphere. Let's start with NASCAR. This is a company that hardly needs any introduction. I'd like to invite Chris Whitmire on stage, who will show us how they're using Microsoft Azure to engage millions of excited fans around the world on any device. Before he comes on, though, let's roll a quick video to get your adrenaline pumping on what NASCAR is all about.
So my name is Chris Whitmire. I'm the Director of Broadcast, Production, and New Media Technology for NASCAR. And hopefully we've got some NASCAR fans out there. It's kind of, there we go. That's what I like to hear. And hopefully I saw some fans actually out on Twitter tweeting about the fact that NASCAR was going to be here today. So I'm really excited about that. But today we're going to talk about Azure and what we're doing with it. Now, NASCAR is a huge brand, right? It's a global brand. We have 38 race weekends over a 40-week period of time. We sanction over 360 events throughout that year. We are by far one of the greatest motorsports out there in the world. But today, we're going to talk about IMSA, right? So NASCAR is a sanctioning body for all these different race car series, and IMSA itself is also a sanctioning body, right? So IMSA sanctions Lamborghini, Porsche, Audi, and a bunch of other really great manufacturers. And they have 12 weekends of racing over the period of the year. They start off their season with the Rolex 24, which is a 24-hour endurance race that not only tests the car, but also tests the driver. And this actual weekend, coming up right here on Friday, we've got the Petit Le Mans, which is actually the final race of the season. And in fact, our drivers and our crews and all of our fans will be watching that this weekend. They're all heading there right now. In fact, I'm heading there in just a few hours when I get done here. And which gives us a really good segue about what we're doing here and what we're going to talk about. And today we're going to talk about the IMSA mobile app. So the IMSA mobile app features live video, live timing and scoring, live IMSA radio, and customizes the experience for the fan themselves based on their driver or their manufacturer. And of course, as any app should be, it's available on Android, iOS, and Windows as well. We put that all together in 13 weeks. See, when we first came up with this idea, it was around Rolex 24, which we were tapped out on resources. Developers were all busy, working on a bunch of different projects to make sure that we were successful for our very first race. And we knew that our old app needed a little bit of love, right? Didn't have all those great features. It wasn't available on every platform either. And didn't have live video. So we knew we wanted to deliver more. And so we're going to take a look at our app right now on my iPhone. So here it is. Took us 13 weeks to build this. We built it in Xamarin. So if you guys are not familiar, write code once, delivered, I believe, 2.6 billion devices. We're still working on the 2.6 billion, but we're definitely on our way. So the app actually has two different functionalities. They have when you're not in race mode and when you are in race mode. And right now, the race isn't going on, so we have a different experience, right? So you can catch up on what you may have missed last week or the week before. And so as you can see, I can come in here and select my different series. In this case, I'm going to go with the Tudor series. I'm going to find my schedule. And right here, Petit Le Mans. And so if I wanted to, I could buy tickets. I can now engage with the fan. The fan can get tickets. They can see what's going on. They can see the schedule of events. Of course, we've got standings. Again, loading really quickly all through Azure. And there we are. There's our standings, right? We've got up to 63 different drivers at any given time. We have 4 different series currently listed in here. We have a total of 7 different series that we're monitoring and putting inside of this app through Continental Tire series as well as the Tudor series. And of course, one of my favorite features in here is news and video. And so, as you can see, I'm now delivering full 1080p quality video all from Azure, right? So we're trying to give fans the best experience they possibly can have, whether they're at the track or away from the track. And when we go to live race mode, you're all going to have live timing and scoring, where we're updating the drivers every 5 seconds. So you don't have to be there, but you can experience the race. We offer quality 720p video live streaming from multiple angles, as well as a broadcast feed when available. And as you can see, some really good looking video. So the question is, how do we do it? Well, we used Azure. And actually, interestingly enough, when we went to this, it wasn't just the mobile app we looked at, because we were having some hosting dilemmas, we'll just say it like that. We had some hosting dilemmas, and so we wanted to migrate our entire platform, right? And that's one of the great things that Azure allowed us to do, the ease of use of migrating a full stack. And in the case of IMSA, we're a full LAMP stack facility, right? Linux, Apache, MySQL, and PHP. We're very open source. You'll notice I'm using a Mac right now. All of our developers are open source guys. And with that being said, we wanted to migrate that over. And within a few clicks, we migrated our entire instance. And that allowed us to be very dynamic and continue to grow as more and more fans came to the website and made more and more requests. So really quickly, we're going to talk about push notifications. So I'm going to go to my content, I'm going to add content, and notifications. So upon clicking on here, what you're going to see is we have just a few lines of code that we've enabled that now I can push notifications, or my CMS will hang up, like any good demo. We're going to push notifications, and what they'll allow us to do is not only manage it from our Drupal CMS, but also deliver it to our mobile fans, giving our web admin one simple pane of glass to manage everything he's been working on. And so, yeah, I might not be connected to the internet very well here. So we'll skip on to the next slide. There we go, okay. So what we built here in a matter of the past few months, we have Azure Web Apps on PHP, migrated completely from a different hosting partner onto Azure. Azure Push Notifications, also known as Azure Notification Hub. We do all of our monitoring with New Relic. All of our backups are being pushed to blob storage. Azure Mobile Services enabling our fans to get that live data, as well as we have an API running on the background. Xamarin, which allowed us to write the code once and use it many times. Azure Redis Cache, again, allowing us to not hit our databases directly, but giving us a buffer that we could use. Microsoft SQL, because at the end of the day, we are an SQL shop for all of our long-term archive data. GitHub, again, our team is open source, and they were happy with GitHub. So now when I take a branch and I push it to master, it automatically updates my website. No revisioning that I need to do, any of that crazy stuff. Just set it, forget it, right? And of course, MySQL. We're actually running Linux servers out there in Azure, where we have our MySQL stack running, and that allows us to have redundancy inside of there and keep the developers happy with how they were running those services before. And so, what did we learn through this entire thing? Well, we gained push notifications, easy with just a few lines of code. Infinitely scalable. As more users come to the site continues to scale with geo-redundancy. So I have really no concerns there whatsoever. And of course, it operates on any device because we use Xamarin. It's open source friendly, right? We wanted to stay in a LAMP stack, and we did. And we have a single pane of glass to monitor everything, from our storage to our resources that are in use to our push notifications. And it was all built inside of Azure. Thank you.
Great job, Chris. NASCAR's story shares a great example of how Azure services help them reach customers on any device. You know, it's important to not only reach customers on any device, but also reach them with the right content at the right time. And to help with that, I'm excited to announce today that the Azure Engagement Service, mobile engagement service, has reached GA and is now available for purchase under full SLA. The mobile engagement service provides real-time actionable analytics with integrated push notifications that help you engage customers based on real-time app usage. Another key method for reaching audiences in every corner of the world is via Content Distribution Network, or CDN. And the Azure CDN provides the ability to deliver apps with optimal performance by serving your app content from the nearest location to your users all around the world, reducing latency and increasing the resiliency of your app. Today, I'm excited to bring you a major new development with Azure CDN. Microsoft and Akamai have partnered together to provide the world's #1 leading service in CDN to every Azure customer. Akamai is the world leader in CDN services. With more than 2,700 locations around the world, they're unmatched in scale and in experience. Microsoft Azure is the only cloud provider to offer this level of integration with Akamai. And we're really excited about the partnership that we're announcing today. To learn more about it, go visit our website at azure.com/CDN. Now, I've spoken with many of you, and if there's one theme that always stands out, it's the pressure you feel to get things done more quickly and efficiently than ever. And so I thought immediately of a customer that I wanted to bring on stage to help give us a story of the journey they've been through and the technologies and processes they use at Alaska to deliver great results for their company. So let me introduce Mike Larengo, Director of ITS Architecture and Strategy. Thanks, Mike.
All right. Thanks, Bill. At Alaska, we have a cloud-first, mobile-only vision, and we're leveraging some key technologies in Microsoft to achieve that. What I want to first is add a little context around that. So if we go to the next slide there, thank you. Over 70% of our workforce is truly mobile. They don't sit at a desk. Their office is at the airport, on the airplane, or on the ramp. And they're always taking care of our customers. Because of them, we've been recognized as having the highest customer satisfaction of any traditional carrier in North America 8 years in a row by J.D. Power. We've given our employees over 10,000 mobile devices to our frontline teams. And we are continually adding more features to put on those devices. We are truly operating in a mobile world. We now have more mobile devices than desktops. We started small at Alaska, born in Alaska in 1932, flying a single airplane from Anchorage to Bristol Bay. Today, we fly over 100 destinations in Canada, Mexico, across the mainland United States, Hawaii, and of course, the great state of Alaska. We've added 3 new routes in September, and I'm proud to announce that in October, we're flying to our 4th country, Costa Rica. Now, when it comes to the cloud, we have a similar philosophy. Start small, think big. And we began our journey with Azure earlier this year and now have 5 applications running. We've identified over 100 applications or services that we're targeting for future cloud deployments as we move forward into our journey into the cloud. And we're leveraging Azure App Service. We don't want to maintain the underlying infrastructure, the OS, the patching, and the upgrade, all that entails. Instead, we want to focus on delivering business value quickly. And we're also taking advantage of our continuous delivery model. where we can basically leverage automation and build and commit and deploy using continuous integration and deployment to kind of speed that, increase our velocity as we speed delivery of that business value to our customers. Now, as an example of that starting small, thinking big, I wanted to give an example of an application that we're working on, and it's introducing a whole new experience for our employees for standby travel. As employees of Alaska, we enjoy standby travel benefits, allowing us to fly on all the great destinations that Alaska serves. But our current solution was basically a classic ASP website. It wasn't responsive, and so when employees need it most, when at the airport, they basically had to go into this website, and it was a poor experience. So a team of volunteers set out to basically transform that employee experience, and we wanted to make it available on all 3 mobile platforms as native apps. So we leveraged the Xamarin tool set for that. And we wanted to send out the day of flight, and then also, as we're kind of doing this continuous delivery, get feedback from our users about what new feature they would like in the next app. And so we're leveraging Xamarin for that cross-native platform experience, and then we're also leveraging Azure App Service on the back end so that the team can focus on delivering the experience to our employees. And as our CIO likes to say, be scrappy, not crappy. And so we're also standing on the shoulder of giants. Those people before us, we're actually making a hybrid model call to our services on the back end using Azure API Management. And I'll talk about in a second. But first, what I thought I'd do is I'm going to do a few things. I'm going to go through a demo of Hopper, the application. I'm going to show how we're provisioning some of our environments through automation and using Azure Resource Management and JSON templates. And then I'm going to show you kind of how that we speed our workflow using Visual Studio Online, where I can actually commit, build, and release using build and release management in Visual Studio Online. So with that, I'm going to switch over to the iPhone here. And I'm going to show you, I've already got my listings up, so we can switch over. What you'll see here is this is my listings. I'm actually heading out to Boston tomorrow. If I go look at that, what I'll see is I'm probably not going to get on no open seats. In the past, what we'd have to do is we'd have to go out and go log on to the website and see whatever the other alternate flights that we can do. Our employees have given this feedback via the app, and I actually have a new release here. And you'll see there's, hey, I can go and see what are the other ways I can get to Boston. In this case, I'm pulling it up, and I say, actually, I might be able to get out on a red eye tonight. So that's just an example of how this team is starting small, thinking big, delivering new features. And as an example of what we're using in the background, we also have the feedback in the app, so I can rate my experience. And this will be making a call back into Azure App Service and storing it in SQL Azure. So I'm going to rate my experience, and I give a little note here and give a shout out. Hey, Hopper team, my day is awesome now because of this new release. Okay, we'll do that. We'll tap that. I'll send that, and that's going to send it back. Thank you for your feedback. We're continually enhancing the app. All right? So what I just showed you there was that kind of iterative development that the team is currently doing. And again, it's a volunteer team that's doing all of this. What I wanted to show next is, if we can switch over, and this is our environment. This is actually a demo environment that I have running in Azure. But you'll see that I have a website or a HOP resource group here. And what I want to do is provision kind of the production environment using Azure Resource Manager. So I'm going to go to Visual Studio here. And I have a script here, a PowerShell script. We make this part of our release deployment. But I'm just going to show you how easy it is to deploy something. We have the parameters here, or the resource I'm going to deploy. So I'm going to right-click on this here, execute script with parameters, and I'm going to use the production parameters. And it's going to go ahead. Oh, it's going to prompt me to sign in here. Just do that. And what it's going to do is it's actually going to start kicking off building a resource in Azure. And so I'm going to flip over there, and we can quickly see it's going here now. It's starting it. I'm just going to go over here, and while that's going, I can just maybe refresh this, and we'll see now I'll probably have a HOP resource group that's being built out in production using Azure. So again, that's automating all that, so we don't have to go click all this stuff. We can just focus on doing our work. So what that's deploying is I have a QA website here, and this is the app web page that we use to kind of tell people about the features, what we're doing, and they can download the app and provide feedback. Oh, looks like it's done. Flip back. So And here's an example also where we're using Azure App Service to pull information from that SQL database. And I can refresh the feedback here, and hopefully we'll see our feedback from me saying what a great job, and see how it is, and get a shout out to the Hopper team. Day is awesome, right? So that's just an example of how we're using feedback to get into the app. The last thing I want to show you from a demo perspective is just how we commit that code and how we go through release management. So here I'm actually just highlighting how we're going to update the web page with the information about the new release. I'm going to go over here, I'm going to commit the code. I'll say new release. I'm going to commit that. That's going to commit that to Visual Studio. And actually I got to sync that first and push my commit to the master. And it should be initiating the push. And now I want to show you is what we're going to see on Visual Studio Online, how that's going to happen. So if I go here, it's check maybe the queued builds. There it is. That's queuing up. And I can actually see the build happening here. And so this is actually building in the cloud, pulling that together, and we'll start deploying into Azure. And I'm going to go over to our release management tab over here while that's building. Do a quick refresh. And we have different environments. We have dev, we have QA, and we have production. And it hasn't yet done that yet. We'll come back to this. I'm going to show you how we all put it together by going back to the slide, and then we'll come back to this in just a second. So if we go back to the slide, and I want to give an overview of the application. So as I mentioned, we're deploying to all three platforms, native applications using Xamarin. We're making calls to the mobile API to put our feedback in Azure App Service, and we're all deploying the web app in Azure App Service. We're also leveraging services built in our on-premise data center using API management. So again, that's how we get that information about the flight. Okay? And then finally, we use Visual Studio Online to show how we do this commit, deploy, get that workflow going to continue and focus on adding new features to the product. With that, let me just do a quick step, and if it hasn't quite finished yet, what we'll do is we'll just continue on. It looks like the build has worked. I'm going to come over here to our release management, refresh that, and we should see maybe that the steps are progressing. And actually, dev is completed successfully. I'm not going to go all the way into production, but I will show you what we have here in production, what I did in QA, is the ability to approve or reject the deployment. So I'm going to say, let's release this to QA. Oops, QA. And we'll go ahead and approve that. And that will start the deployment to QA. Now, if I should be able to see that feature, it's going to take time for the thing to spin up. We can come back to that in a second. If we can go back to the slide, I just want to sum up kind of the start small, think big philosophy. Really, you know, what we did is we identified an app that has high visibility, but low priority. We care more about, we focus more on our critical system and our customer-facing systems. But we found an app that is actually highly visible. Leverage app services to focus on delivering that business value and less on the underlying infrastructure. And then adopt a continuous delivery model to increase the velocity and the quality with which you deliver that product. We saw how we use gather feedback via the app and how we cycled that back in to the application and just building this kind of rinse and repeat and expand that. And then finally, share your story. Share your story within your app, within your company, with your friends. What we found is people have learned from us, but we're also learning from other people within the company. And that's how to make it successful. I see over here, if I can switch, just to show kind of in dev to my desktop here, we'll see the new release, same-day flight nodes are now published. So with that, I want to thank you very much for your time.
Great job.
Thank you.
That was awesome, huh? If you're interested in building an app just like that, using Xamarin Tools and Azure App Service, we've got something for you to try. Check out aka.ms/trymobile, where you can find an open source project that Xamarin worked with us on, with all the source code available to show you both on the client and the service how to build a great application just like Alaska just showed us. You know, you probably noticed a theme here. You saw with Alaska an employee-facing application. You saw with NASCAR a customer-facing application. And with Earlier, you saw a consumer with e-commerce application. All of these apps running on Azure App Service. This extremely popular service is used by more than 60% of our paying customers today. It hosts hundreds of thousands of applications worldwide and transacts billions of requests every single day. App Service hosts all kinds of modern apps, web backends, mobile backends, APIs, and even logic apps or workflows. App Service provides auto-scale and auto-patching, of course, and it supports all the popular languages that you use to build apps and APIs. It also integrates with all of the source code control systems that you use. So for continuous integration from GitHub or VSO, Bitbucket, and more. Earlier this year, we announced App Service Environment. This is a fully isolated environment to run your apps. App Service Environment provides you the ability to scale to billions of requests every single day with dedicated front end and back ends that you control. This gives you full isolation from other tenants, and it's ideal for corporate apps and data. In fact, App Service Environment lets you connect the service environment to your own VPN network with high-speed VPN connections that allow you to have hybrid-type applications with connections to on-premise databases and services. Today, I'm excited to announce the general availability of Azure App Service Environment. This means you can run your own environment in production and enjoy a fully supported SLA, starting today. Now, having worked in this space for a while, I can say definitively there is no one-size-fits-all solution when it comes to application platforms. One thing we embrace at Microsoft is the requirement to have a variety of options available to satisfy the diversity of developer preferences and application needs. This is one reason you see us embracing excellent solutions from open source and offering open source-based services like Hadoop, our Redis cache service, Linux VMs, and support for Docker, just to name a few. Scott mentioned earlier that we're introducing a new Azure Container Service built on open source Apache Mesos in collaboration with Mesosphere. This service helps with overall management of Docker containers, and it'll offer a new powerful abstraction for running apps in the cloud. And to tell us more about this and show us a great demo, I'd like to introduce Ben Hinman, co-founder and CTO of Mesosphere, as well as Mark Rasinovich, our CTO.
Thanks. Hi, everybody. It's awesome to be up here on stage at AzureCon with Ben Hinman, the co-founder of Mesosphere. So what do you think of this t-shirt?
Looking good, Mark.
I've got one burning question, though, and that's why isn't this black? But that's not why you're here, not to answer that question. Tell us why you're here.
Yeah, so it's great to be here to talk about the collaboration that we've been doing with Microsoft around the Azure Container Service. In particular, I wanted to talk about Apache Mesos, which is the technology under the hood that's helping to power the Azure Container Service. So Apache Mesos is a distributed systems kernel that really helps you to abstract away all the resources in your data center, like CPU, memory, storage, so you can treat them like it's one big computer. And then you can go ahead and you can build and run applications on top like it's just one big computer. The project started in 2009 at UC Berkeley by a team of us, and since it's been adopted by a handful of companies, including Twitter, PayPal, and Apple.
Oh, so Twitter. So is Mesos part of the reason we don't see fail whales so much anymore?
That's an interesting question. In fact, it played a really big role. So in the early days of Twitter, it was a giant monolithic Ruby on Rails application. And the process of breaking down that Rails application into a bunch of microservices and getting those scheduled via Apache Mesos is really what helped us increase the reliability and scalability of the site. And I think one of the great things about having Mesos be a technology that kind of went along in this journey at Twitter is it helped us get it to this high scalability production environments that companies are using it in today.
And that's Apache Mesos, and that's completely open source, right?
It's completely open source. I assumed that's kind of...
No, in fact, it is. We love Linux. We love Docker. We love Mesosphere.
That's a lot of love, Mark.
Well, we got a lot to give. So tell us how Mesosphere and DCOS fit in the picture.
Yeah, so what we're doing at Mesosphere is our vision is to be able to take the Mesos technology and make it available for more than just the Twitters of the world. And we're doing that with the Data Center Operating System, or DCOS for short. And when we first started chatting with Azure about what you guys were interested in doing with the Azure Container Service, we realized that there was a great opportunity to be able to take both Apache Mesos and some of the open source components, so open source some components to DCOS to actually create the Azure Container Service.
So tell us about some of those open source DCOS components.
Yeah. So there's a bunch, of course, including Mesos. I think the two that I'll really focus on is Marathon and Kronos. Marathon is a service that helps you run long-lived containers, and I think we're going to see a demo of that in a sec. And then Kronos is for running batch containers or cron-like workloads.
Yeah. So from our perspective, the reason that we chose to build Azure Container Service on Mesos is that when we go out to talk to customers about orchestration, many of them tell us that they already have real Mesos deployments going on already, and that includes both startups and enterprises. Plus, bringing Mesos into Azure gives the Azure community the Mesos ecosystem and gives the Mesos community the Azure ecosystem. And our work with you guys with Mesosphere on bringing Mesos to Windows Server and Windows Server containers means that we're going to have the most flexible container service out there.
That sounds great. I think it's time for the demo.
All right, let's check it out. So what I've got here is I'm going to show what the experience would look like for deploying a Mesos cluster on Azure through the container service. I'll click here and press the Create button, and we'll start. And what I'm going to get asked here is a few questions about how I want to customize my Mesos cluster. The first thing it's going to ask me is what I want to name it, and I'm going to call it AzureCon 1. And this asks me the username that I want for managing the cluster, plus a password for that username. And I think I've mistyped the password, so let me type that again. And then it'll ask me what resource group I want to put this in. This is entirely built on top of Azure Resource Manager, so I'm going to call the resource group the same name I gave the cluster, and press OK. Now here I get to actually customize the Mesos cluster itself by specifying the number of agents or slave nodes that I want in the cluster. And I'm going to specify 10 here because I've got I want a fairly sizable cluster. And because I want this to be a highly available cluster, I want the Mesos masters to be scaled out so that they can perform highly available replication. So I'm going to select 3 here. And then finally, in this page, a DNS name for the container service, and I'll call that AzureCon 1 again. And then the next screen, I get to customize some more aspects of this Mesos cluster, like which jump box OS I want to connect to actually manage the VMs in the container service, as well as whether I want Swarm, Marathon, or Kronos application frameworks deployed to it. So I'm going to leave those with the default. And then the final question I get asked is the name for the jump box itself, the VM that I'll connect to manage the container service VMs. Then I get a summary screen, and pressing OK, and in a few minutes I'll have a fully managed Mesos cluster ready to go. I've already done that a little bit earlier, so I've already got one here called AzureCon. And just to give you an idea of the complexity under the hood of just pressing that OK button and what it creates, here's a list of the resources that are created as part of a cluster like that. So a huge number of resources, virtual machines, NICs, load balancers, availability sets. So let's switch and talk about the DevOps experience now for using a Mesos cluster from Azure Container Service. And I'll start by opening Visual Studio Code, and what I've got here is a Docker Compose file, which is a file that describes a multi-tier containerized application. This application consists up here of a load balancer built on HA proxy, a web server, and then a back-end Java containerized application that will serve the REST APIs for that web server. To deploy that on my dev system, I can simply type Docker Compose up-d, and if I type Docker PS to look at the containers that have just launched, you can see that I've got one of each of those containers. In my dev system, I can also choose to scale out one of the components, one of these applications. So I'll scale out scale web equals 3 to create 3 of those web servers. And if I type Docker PS again, you're going to see that I've got 3 of those Apache foreground web servers running. So that's scaling in a dev system so I can do my dev test, but now I want to take that thing to production and I want a lot bigger scale in production. So I'm going to switch over to this view of the Mesos cluster. So I've connected to the Mesos interface in that running cluster that we saw AzureCon, and you can see that I've got 10 slaves here activated, and the cluster itself is completely idle. You can see that I've got 10 CPUs down here ready to go and serve requests. Zoom out here. Now, the first thing I want to do is show you that in Marathon, I don't have any of those containers running. Marathon, the long-running framework. So let's go and deploy that same application that I just showed you in my dev test environment by typing Marathon compose. And that's just going to deploy that same compose file. And if I go back to the user interface here, we're going to see that we get each of those containerized applications, my front end, my middle tier, and so they're deploying right now from inside of Marathon. We'll just give it a second here, and we should have the load balancer finish deploying. And now we've got everything running. So we just deployed that same application with the same scale that we had in our dev system, but I want to scale that out. So what I want to do is go to the website and use the scale button here and scale that out to 20. I want 20 of those instead of just one. And I go back to apps. And what we're going to see is that a number of those have actually deployed, but not all 20 of them. We've got 12 that are sitting there waiting to run, and that's because the Mesos cluster that we've created is too small to hold all those web containerized instances. So we need to scale out the cluster itself, and to do that, I'm going to go back and run a container service API, a command, by scaling that cluster up to 30 VMs. And now we go back, and in a few seconds here, we're going to see this scale out. Underneath all of the container service, we're using Azure Resource Manager with the power of resource groups to create what are called scalable virtual machines or virtual machine scale sets. So what we do is define one virtual machine configuration for the virtual machines that are part of the cluster, and then we simply specify a scale count, as you saw me do, and Azure Resource Manager takes care of just making clones of that virtual machine template. So we can manage huge numbers of virtual machines as a single object, scaling them up, scaling them down, and even deleting them. So in a few seconds here, after those virtual machines have scaled out, we're going to see this number go back up to 20. And just give this another few seconds. Oh, maybe I'll type refresh. Let's see if we've got a browser refresh issue here. And all right, well, maybe we're going to have to wait a little bit longer than normal for this. Again, it is a preview that we've got, a pre-production code. We are going to be releasing a public preview of this shortly. And check out Ross Gardler's AzureCon demonstration later. He's going to have a video where he's going to show you more demonstrations of this and actually, hopefully, a successful scale out once we fix this, whatever is causing this issue right now. So with that, I'm going to turn it back over to Bill.
Awesome.
All right. Thanks, Bill.
Thank you so much for joining us at AzureCon today. We've had a chance to see how developers can take advantage of Azure services to engage audiences on any device, innovate rapidly, and stay agile. We've announced new partnerships, released GA services, and brought you even more flexibility and choice through our continued partnerships with open source. We have some exciting content in the breakout sessions covering all the technologies we've shown today, and I encourage you to check them out. Thanks again for joining me today. I look forward to talking to you more soon, and please stay in touch.